In this video, I'm going to explain how to find the interior angles of a unit circle. Interior meaning the inside angles of a unit circle. So a unit circle is comprised one revolution, that means one time around, is 360 degrees. This is what I'm going to call the starting line. That's definitely an Anne Bradley term. That's not a mathematical term. We're always starting here when we're going to measure angles. And we go specifically up to the line we want to stop at. And then we ask, like, for instance, if I go from here to here, I'd ask myself, what is this interior degrees? Or from here to here, it's a straight line. What is this interior degrees? Can we go backwards? We can. We could go clockwise, but that would represent a negative angle measurement. So we're going to stay right now with just positives. So we have 360 degrees, and if I take the 360 and I'm going to separate it into 4 portions, those portions are called sectors. A lot of students can relate to looking at a pizza. Each one of these would be 90 degrees. So this is 90. I'm going to write 90 degrees up here. Here's 180. When I take 180, I add an additional 90. I'm up to 270 degrees, and one full revolution is 360. Now, you don't have to stop there. You could keep going, right? We could do 360 and 360 is 720 and so on. If I take the unit circle and I split it here, half of 90 is 45. Same thing here. I split this 90 by 45, and by 45. So if I take 90 and an additional 45, I would be up to 135. If I take 180 and an additional 45, I'd be up to 225. Same thing, 270 plus an additional is 315. Now, I will share with you a shortcut. Students have shared with me a shortcut that they're able to memorize this a little bit easier. So they say, when you're doing the 45s, which I'm going to just circle those right now. This marker appears to be dry. Let me grab another one. These 4 marks right here that I'm going to do with a yellow. This is how I've heard students tell me. They said, hey, start with a 4. So there's a 4, add 9 to it, 13, add 9 to it, 22, add 9 to it, 31. Again, start with a 4. Then put a 5 behind each one. And that's also an easy way to come up with these angle measurements. Again, start with 4, add 9, 13, add 9, 22, add 9, 31, put a 5 behind each one, and that represents this measurement. So from here to here is 45 degrees. From here to here is 135, here to here, 225, and all the way back to this point is 315. In this particular video, we also went over those 90s. So up to here is 90 degrees interior, 180, 270, and 360. The next part you're going to see is we're going to talk about these other ones that were not mentioned in this particular diagram. So let's start over here. From this starting line up to this point is 30 degrees. This is 30 degrees. And if we continue to add 30s, it looks like this. There's 30, another 30 is 60, and then we're up to 90. Those are 3 equal sectors. A sector is like a slice of pizza, has this rounded edge of a circle. So 30, 60, 90, and we can continue to add. Students have also shared with me in the past that they have a faster way of doing this, and for some reason maybe it's easier to add by 3s than it is to add by 30s, but they say they just count by 3s and throw a 0 behind. So 3, 6, 9, 12, 15, 18, 21, I gotta count right, 24, 27, 30, 33, and 36. Then make sure you throw a 0 behind everything. Once again, these are the interior angles of a triangle, so of a circle. So from here to here is 30 degrees. Just examples, that's 90. That's 150, this interior. From here all the way to here would be 210, from here all the way to here and so on. If I wanted to go to 300, it's here all the way to this point. So these are measurements within degrees. So I've gone over the 30s, 60s, and also over the 45s. So a trick again, how can students quickly do this? Just to demonstrate, a trick, as some students like to go when they're given this, they like to go by 3s. So 3, 6, 9, 12, 15, 18, you just saw me do this, 21, 24, 27, 30, 33, and 36. Now I'm going to go back and put zeros behind. Now I'm going to go through and I'm going to do the same thing, the tricks with the 45, the tricks with the 45. So you're going to wear 45, that's where I'm doing these little red dots. Everything else I've accounted for an interior angle. So I'm going to start with 4, add 9 to it to get 13, add 9 to it to get 22, add 9 to get 31, and throw a 5 behind. Okay, I have represented the basic. I've represented the basic interior angles of a unit circle. Now, there does exist 20 and 15 and 10 and 1 and 31, but these are the basic ones we're going to talk about. This is in terms of degree, so each one of these should have a little degree measurement behind it. Just like we describe distance in many ways. For instance, we describe distance in terms of miles, and other parts of the world we describe it in terms of kilometers. We describe these interior angles in terms of degrees, which most students connect easier to, and we also describe them in terms of radian measurements. So now I'm going to discuss radian measurements with you. Give me 1 second. All right. So the same points we just did. I'm going to start off with the top of a circle. And I'm going to do the 45. So it's not necessary for me to do that. I'm just going to do the top of a circle. Top of a circle. So in the top of a circle, there are 4 equal sectors that are all 45s. I should have been a little bit neater about drawing this particular one, just so there's no misunderstanding. There are 4 equal sectors that are all have interior angles of 45. So this is a distance of 45 degrees, 45, 45, and 45. So I start with, this is 1, the first one out of 4, attach a pi. This is the second one out of 4, attach a pi. This is the third one out of 4, attach a pi, and fourth out of 4, attach a pi. And then I'm going to continue. Notice I'm doing every 45. So here's the next 45. This is the 5th out of 4, the 6th out of 4, the 7th out of 4, and and way up here is the 8th out of 4. So I've gone through and I've done each one of these. And you're wondering, what am I doing? So instead of representing this angle with saying 45 degrees, 90 degrees, 130, 135 degrees, 180, 225, 270, 315, and 360, I've now represented them in terms of radians. Do you have to know both? You do. Now, when it's possible to reduce, we want to reduce. So I know 1 over 4 doesn't reduce, but I do know 2 over 4 reduces to 1/2. 3 out of 4 doesn't reduce, but I know 4 out of 4 reduces to 1. 5 out of 4 doesn't reduce, but 6 out of 4 reduces to 3/2. 7 out of 4 doesn't reduce, but 8 out of 4 reduces to 2 pi. Next, I'm going to go through and represent all of the 30s. So let me go through here and go over each one. And I want you to count how many equal sectors do we have in the top half that are represented by an interior angle of 30. So there's one group of 30, there's a second 30, a third 30, a fourth, a fifth, and a sixth. If you are struggling to see that again, some students, there's 1, there's 2, 3, 4, 5, and 6. So this is the first one. From this being the starting line, this is the first group, and there's 6. So 1 out of 6, 2 out of 6. This would be 3 out of 6, but we know 3 out of 6 is the same as 1/2. This is 4 out of 6. I can continue to attach a pi. 5 out of 6. This is 6 out of 6, but 6 out of 6 is the same as 1. 7 out of 6. 8 out of 6 is right down here. 9 out of 6 is the same as 3 over 2. This is 10 out of 6 and 11 out of 6. So now I have accounted for every one of the points. We just want to make sure that we reduce. So I'm going to show you a picture that is fully done, and we can compare the two. In this picture, you're going to see these ordered pairs on the outside, and you will review that and achieve both the mathematical structure method to achieving these ordered pairs and also learn a shortcut. So let's start with just the shortcut of the 30s. Again, I want to go over, so this is my 30. I'm looking for this angle. And up top, there's 130, there's 2, 3, 4, 5, and 6. So I'm going to put the denominator out of 6. That's why this is 1 pi over 6. This would be 2 pi over 6, but we know 2 pi over 6 is the same as 1 pi over 3. This would be 3 pi over 6, but 3 over 6 is the same as 1 over 2. This would be 4 pi over 6 reduced is 2 pi over 3. This is 5 pi over 6. This is 6 pi over 6, the same as 1 pi. Here's your 7 pi over 6. 8 over 6 reduces to 4/3. 9 over 6 reduces. 10 over 6 reduces. 11 over 6, and right here, ending one revolution would be 12 over 6, which is the same as 2 pi. So I'm going to circle the ones that we've gone over. These are my 30s. 1 over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And when possible, I always reduce them. The next is going to be the 45s. So here's one group of 45, 2 groups, 3 groups, and 4, just to clarify. So that's why the denominator is 4. Here's 1 over 4. This would be 2 over 4. 2 over 4 reduces to 1/2. This is 3 out of 4. This would be 4 over 4 reduces to 1. 5 out of 4. This would be 6 over 4 reduces. 7 out of 4 and 8 out of 4 is the same as 2 pi. Okay, in this video, I've covered both to start with how to construct the interior angles of a unit circle using degrees and then using equivalent radian measurements.